Welcome back from the break. I think next time we have coffee and pastries in the room. That's always the safer way of keeping everybody. The next two speakers will provide, I would say, more North American perspective on sustainable urban planning, and as I said earlier, provide you with kind of a baseline idea of what is currently at the forefront of practice being done. So the first speaker is Greg Havens. He's a principal at Sasaki. He is there mainly responsible for their master planning and design branch. He developed their sustainable system framework for analysis of urban environments that he's going to talk about. And he has a degree in master city planning from MIT. So I actually wasn't aware how many MIT graduates we have here, but that's great. Thanks a lot, Greg, for joining us. And let's help me welcome him.
Well, thank you, Christoph. It's great to be back on campus. I haven't been here in quite some time, but always good to come back, and thank you for the invitation today. What I'd like to do is go through what we've been doing within the practice to develop a comprehensive methodology for addressing sustainable solutions for universities, for cities, and for various institutional clients we work with. The process that we've developed is really about education, trying to help people understand the range of issues that we'll be addressing in a planning process, the issues of sustainability, and what are some of the key metrics. And if you're going to lead people through the process and have them come along with you, developing this framework was really what we were intending to do in this process. So as we all know, it's about bringing these three elements together, the triple bottom line, if you will. But how does one go about that in a planning process? How does one educate people? How does one educate a population that may not be familiar with what the notion of sustainability is? So as a result, we internally developed what we call our Sustainable Solutions Framework. And this is intended to bring together those elements, but also make them applicable to the range of scales that we work at, for anything from a new city in China to a campus master plan, to a building, to an interiors project. So a range of scales that we deal with in our work. So our goal really is to create a work that is resilient, one that addresses these multiple scales, and the one that gives you enduring solutions for the range of sustainability issues that will be addressed in the project. So over the past few years, we've been looking at our work comprehensively across the practice, and how does it perform relative to energy, and really beginning to develop metrics around that, and how do each of these projects perform, whether it be an interiors project or a city scale project. Looking at climate, and we work all over the world, so therefore climate really becomes an initial point of reference for us. How do we respond to the various climates within which we work, and what are appropriate solutions for those climates? Ecology, again, because the sites vary and the scale of the sites can be vast, several square kilometers down to a few hundred square meters. The issue becomes, how does one deal as part of a broader context? And we have this notion of always embracing that next level of context in the work. Water, and again, depending on where you're working, what are the water issues in the region? What are the key metrics one would look at? How does one produce a design that is appropriate for the water issues in that particular region? Mobility, because we come from a planning background, we are dealing with transportation. And so we like to refer to transportation not just as moving cars around, but how does one walk, bike, use transit, and how does one even embrace the car? But how does that function as a system, and what are some of the outcomes we seek to achieve in doing that? Focusing on the experience for people becomes part of the key initiative there. Looking at materials, how do we source materials? Where do they come from? Are they appropriate for the region? Do they perform well in the climate? Do they perform well in an interiors project, which again, we work at that scale as well. So trying to look at materials on a comprehensive basis. And then finally, community. It's about people ultimately. So how do you create places for people? And places that are culturally responsive. Again, looking at where you're designing, who you're designing for, and what might be their particular issues. So how does one apply the framework? Now, what I've shown you is sort of the overview and some of the, just a flash of some of the metrics that we've been trying to work with. Now, an example from a university environment, which is, in many cases, we work with urban universities, but a university environment provides you with the opportunity to deal with many of the issues you deal with at the urban scale, but importantly, there's one owner. So you're able to really address these issues more comprehensively than perhaps you would at a city scale. So the Sustainable Solutions Framework applied in an urban, for an urban university might look something like this, where we begin with people. Who are we serving? How many of them are there? And what might be the impact on the environment? What is the mission of that population? What are they trying to do as an institution? And as a result, how does that impact the environment? How does that impact the way in which they organize themselves? For example, if they're pushing research, that becomes a key initiative. Thank you very much. That's great. With many institutions, land use as athletics become an important consideration. Also place, tradition, history, and what's the sense of community they're trying to develop in that environment. The issues you would expect us to get into would be all of the environmental factors we all deal with in our work, whether it be land use, landscape, the space implications, et cetera. But what we seek to do in the framework is to develop a goal for each of these areas, conduct appropriate analysis that informs the way we would look at these various issues, and then begin to set metrics for various time frames. So where are we today, and where do we hope to be in, say, 10 years' time? So the element of time becomes a key consideration in how one looks to the future and how one brings a population along through this process to help them understand that if they want to achieve their goals, they really have to think about the future. We look at resource flows, and this would be everything from potable water to energy consumption, and increasingly working with institutions, energy planning around emissions. Many institutions have signed commitments to reduce emissions. So what might that mean in terms of how they go about getting there? Materials, again, how do they source and procure products? How do they source and procure building materials, and what is the environmental impact of that? Recycling, a big initiative in obviously many communities, but what do we need to be doing to plan for recycling, not only at the site level, but operationally? How does that work within a community or even a campus environment? And then finally, finances. How do we pay for all this? What are the operational issues that one encounters? That can be a significant issue. With institutions, research and research funding. Research is a huge energy consumer on many campuses, so how do we think about that, and how do we help think about research in maybe a different way? And then partnerships, and this applies to communities as well. What partnerships are necessary to really create a solid community, a good quality of life, and one that I think helps achieve some of the initiatives we heard this morning around cogeneration of energy, sharing of resources, et cetera. So if we think about people, and this is where it really all comes back to. We're designing for people and how in their patterns of activity, what they hope to do in these communities or these environments. And a key consideration that we always begin with, well, who are we designing for, where do they live, and what impact might they have relative to their own commuting patterns? So let's say for a campus environment where you are bringing thousands of people at some distance every day, the environmental impact can be significant. So what might be some of those considerations? If we think about patterns of use over time, another element, this happens to be from a university in the southern United States, where if you look in the summer, the enrollment drops dramatically, but the electricity consumption and water consumption go up dramatically. That's because they're air conditioning space that no one's in, and they're watering lawns that no one's really using. And I don't mean no one. There are people there, but certainly these environments are built for much larger populations and are not functioning at that level. So it begins to suggest that there may be an operational issue we'd want to think about relative to these environments and getting more out of them, being more efficient. We also think about community, and we go through extensive mapping exercises where we look at what surrounds an institution, whether it be commercial or other cultural initiatives. How do we really begin to create partnerships and opportunities for collaboration, and really through a planning process, bring these people together so that they see the potential for future engagement. Now, some of the areas that we typically get into, as I think many of you would in your work, would be starting with climate. As I mentioned, we work all over the world, so we have to think about the issues of climate and how does that influence the way you would lay out a master plan. And we've heard a lot about that today. But understanding orientation and wind analysis, this becomes a part of our analytical process of how we arrange buildings relative to the region within we're working. But also building spacing and for comfort, for energy efficiency, what are those optimal dimensions for streets, for plazas, et cetera? That's a key starting point in the analysis. As are urban heat islands, looking at the various temperatures and the materials and how they perform relative to heat absorption in that particular region. So these types of analyses would inform the way in which we begin to plan urban environments. And then finally, pushing into the buildings in a way that maybe not has always been the case with planning, but really understanding how you arrange buildings, how you configure them such that you do get climates and microclimates, places that are comfortable for people, and decrease the energy demand on a building. Ultimately leading to many, like we've seen many examples like this morning, where there is some sense of how one might design in a very hot climate, in this case, Abu Dhabi. We also work in regions where, just having worked with a number of institutions and cities where they say, well, orientation doesn't really matter. So we try to use analytical methods to help people understand, yes, it does matter. It does matter on your building, and looking at the various seasons. So these methods, I think, are part of this process of educating a group you're working with, helping them understand why these things collectively matter, and the integration that one has to take in developing a plan that's really responsive to the climate, the culture, and the region. That even goes down to how we might begin to notionally arrange buildings, knowing the building types we might be working with, and how we might begin to arrange them on the site, not only for relative to energy, but also when rainwater collection and stormwater management becomes part of the conversation with the client groups we engage. Now, stormwater management, because we come from a landscape background, that's another area where we put a lot of emphasis and work, not only looking at site level management, but also thinking more broadly about a region and how one would design and use best management practices on a particular project. It always begins with an analysis of how much rain does this particular site receive, what kind of landscape would it support, and what might be some of the considerations we would need to think about relative to managing that rainwater and even harvesting it for particular uses. This also gets us into GIS analysis, looking at topography, but also thinking about the way in which open space structures work in a particular community, how that relates to water, pedestrian movement, and even organization of land and landscape. So soil conditions becomes part of the analysis, understanding what will happen with water once it potentially infiltrates the soil, how does it flow, and how does it impact the various sites that you might be addressing in your work. Impervious area, again, and not something that I think would have been calculated, say, 20 years ago in a master plan, but now part of the work, trying to understand what impact are we having relative to the hardscapes that we're creating in a campus environment. How do you measure that? What are the considerations? And how do we make this work as a system? And how do we use best management practices that enable us to decrease the impact of an impervious surface area? As we think about built environment, we're looking at land use, landscape, space, infrastructure, mobility. I mean, I clearly could go into a lot of detail on all of these, but I'm going to just touch on landscape in particular, where we really try to work and develop what we call a working landscape, and that is landscape that not only provides the aesthetic quality you'd want to see in an environment, but how does it function in that climate, in that region? And if we're going to create a landscape in an area that doesn't have much water, how do we then utilize water to the best benefit to help promote tree growth, to help do things that are going to help use water and wisely? So that begins with an understanding of landscape topology and what the various maintenance practices might be with that landscape, how much irrigation might it take. That certainly requires an understanding of the region and what will work in each region. but also the fossil fuel component associated with landscape maintenance. One of the statistics I've heard is every day in this country we mow about an area the size of the state of New York. So the environmental impact of something like that is tremendous. So if we can decrease the amount of energy input into landscape, it's certainly an important consideration. We do work all over the country, and in this case, this is Austin, Texas, where at the University of Texas, we really looked at shade, not only shade contributed by buildings, but also by landscape. So what is the tree cover doing in an environment such as Austin? Uh-oh. And Helmut's obviously interested.
That's my father. That's my father-in-law. Wow.
We can tune him in.
How do I turn that off? I'm sorry.
Okay, no worries. In this case, we did an extensive heat island analysis at University of Texas, looking at the various surface materials, taking temperature readings, trying to map out the human comfort zones. As you would expect in an environment such as Austin, the most comfortable environments were those that were most shaded. And so the live oak trees become an important part of the human comfort strategy. And so strategic tree placement becomes part of this overall master planning effort as well. So that leads us to shade strategies. And I think we've heard a lot about building placement today and how the importance of that relative to shade. But there's also a landscape component to that as well. If we look at a campus environment throughout the day and the contribution of shade throughout the day, it really begins to inform how we think of where trees are placed relative to movement, where people are walking, relative to building placement. And certainly in the southern parts of this country, if you can utilize trees on west facades, east facades, can significantly reduce air conditioning demand. So it's more than just putting trees there for aesthetic value. There's a functional quality to it that we seek to embrace in the work as well. So in the master planning level, there's a shade analysis, certainly in the southern regions of this country, where I tend to do a lot of work. How do we introduce elements in the landscape that might be there initially, trellises, things of that nature that help provide the outdoor comfort, but over time, tree growth will help supplement what those structures can provide initially. So this is an example, again, from Austin, Texas, where we've sought to extend the outdoor environment through simple measures such as these. It really extends the outdoor life. And we heard a bit about that today. It's really this connection to the outdoors and how do we create comfortable environments in a thoughtful way. So it's, again, more than just putting trees and shrubs in. We work in many areas of the country where wind is a considerable issue. And so obviously building placement's important to that discussion, but also landscape can play a role here. And this happens to be an example from West Texas, which I have to say is one of the windiest places I've ever been, where we began to look at how windbreaks used in an environment, an urban environment, could really help mitigate. So what you see here on the west side of this particular institution is a wind modeling analysis that we conducted, with the red areas being the most significant wind, and you can see just behind the tree levels there, the tree layer, a significant reduction in wind speed. This is a strategy used in many parts of the U.S. Historically, but has somewhat been forgotten. And so we look for opportunities to do things of this nature that complement what we're doing in the urban environment. A case a little closer to New England is at University of Maine, where we sought to, in the campus environment, introduce a series of windbreaks that not only were about pedestrian movement, stormwater management, but also help mitigate some of the significant wind issues on this campus. So the windbreaks were introduced and were tailored such that we began to create these zones in protected areas in association with the proposed buildings and thinking about how this campus environment would function year-round. So with the windbreak, depending on the height of it, you can get a calming area of up to 4 times that height. Looking at, obviously species such as evergreens or things of that nature that help mitigate wind for human comfort, but also relative to building placement. It can help decrease infiltration on the building. It can help really create a more sheltered environment for the placement of new buildings. So in this case, the building and the windbreak collectively protect a zone on the south side that would help extend the outdoor season, if you will, for this particular building. We also look at water management and the landscape. And in this particular case, there's several things going on. It was a pedestrianization of a street, but also an opportunity to not only improve the aesthetics, but also deal with stormwater management as part of that strategy. So an integrated solution that would help address many levels of what we were seeking to do in this project. So it's how these things begin to come together in what we call joined-up thinking. It's more than coordination. Coordination implies you would think to do that. Oftentimes, there are things that you can join up and link that you wouldn't, unless you went through analysis, even consider joining together. So this leads to integrated solutions not only at the urban level, but in using existing infrastructure, which I think we've heard several times today. I think like Germany, we've built a lot of North America. So how do we adapt what we've done to really begin to think in new ways as we do renovation and deal with deferred maintenance and things of that nature? With regard to energy production in the landscape, another thing we often look for in established environments is how can established open spaces maybe become geothermal fields? How could they in fact be part of energy production for buildings in the surrounding context? So there might be opportunities depending on where you are, depending on soil temperature and the technologies in use. That could be a consideration as well. Now, I often hear from clients, oh, we've got 850 acres of forest, we're all set. We don't have any emissions now because of that. Well, even if you were to take it, and again, this is at University of Maine, and it doesn't quite work the way I think people believe. If it were to work, it's only about 1.5% of their emissions would be sequestered by their forest. But I think a lot of people out there just assume we'll plant 5 or 6 trees and we'll be all set. And so that is one of the kind of the myth busters. Now, it's not to say you should not plant trees. It's not to say that. It's just the opportunity is not as great as some people would tend to think. Now, we're also dealing with space and looking at legacy. You know, as has been mentioned several times, we've built a lot. What do we do with it? It's the legacy of that space that becomes important. And the way we like to think about this is space and people lead to energy consumption in a building and an environment, which leads to emissions and costs. Now, whether we're here or not, this building is consuming energy. I mean, certainly conventional buildings. So you have to sort of have a new accounting procedure here. I think certainly in a university environment, an institutional environment, this notion of the connection between space and energy is one that many institutions are certainly beginning to deal with. So helping them understand energy use intensity in a multi-building situation. This applies to an urban environment, but I think in this case, most of the red buildings, the most intense, are lab buildings or athletic facilities that tend to consume a lot of energy. So are there ways of operating? Are there ways of certainly constructing and renovating that would improve that situation? That becomes the question. Also thinking about new construction and renovation. If we're adding, in this case, a lot of research labs, well, the energy implication of that, unless we take some initiative and set a target for ourselves and a new way of thinking, our energy consumption could increase greatly. So understanding the impacts of the various types of space that you will be adding or building collectively becomes part of a planning process as well. I've mentioned mobility, and this becomes a key thing, certainly as we think about landscape, context, urban environments, understanding how certainly vehicular traffic works, and this leads to a lot of coordination with transportation planning and vehicle flow. But increasingly, bicycle use. I think it's dramatic what is happening in certainly the U.S. The amount of bicycle use I'm seeing is incredible. But as a culture, I don't think we know how to deal with it quite yet. So, you know, how does one integrate bike movement into a city environment? How to park bicycles? How do you do all those things? It sounds simple, but it can, you know, in an environment such as a university campus that, where you're drawing a lot of bikes, it becomes a significant consideration. And then transit planning. And in this case, we try very much to coordinate it with land use planning. Where are we bringing these people? How can we create nodes or points where we're supporting business so that you're not just delivering transit services, but you're really thinking about how you create nodes where people have services and amenities, and we're supporting business opportunity and in the urban environment. So we have this notion of mobility space, and that is kind of the corridors you travel through, and those need to be more than just streets. We have to really think about all the modes of transportation, completing a street environment that would think about pedestrian movement, bicycle movement, transit, et cetera. How does all that function as a system, and how is it coordinated? That leads to the character of the environment. How does, you have to help people understand what that might mean, especially in parts of this country where auto use is predominant and they don't understand quite how all this could function in a very pleasing and acceptable way. Modal split becomes part of the discussion, and trying obviously to move away from as much of the auto traffic that we have today and move toward an environment where we're balancing things. It's more of a comprehensive mobility strategy. So we've started collecting metrics in our work that happens to be through a new bus line service in Cleveland, where we really think about, well, what might that be in terms of its environmental implication by introducing this bus line, this new BRT corridor through the city. Now, in the resource flow areas, again, a lot of this is trying to help people understand what the implications are of functioning and living in an urban environment in a community. And I think a lot of people have no idea where their water comes from. They just know it comes out of the tap. They don't know the whole process of getting it to them. So what we try to do is help them understand the flow, the sequence, and what the issues are with the way they're consuming water, not only in buildings and infrastructure, but also relative to landscapes. How might we do better in that regard? One of the things we like to do is relate it to, okay, in this particular campus environment, you consume 2 Olympic swimming pools a day of water. Now, that's quite a bit of water, but that people can begin to understand. And again, if we're bringing people through a planning process and education process, trying to help these individuals understand the metrics becomes key. So again, we look not only at what you're consuming today, but where do you want to be? Often they're setting targets. Where do they want to be in 10 years' time? And obviously there are various strategies for getting there. But again, this is the sort of stuff that I don't think communities necessarily understand. Energy, key area as well. Again, what are the flows of energy, and what are the various sources of energy in the comprehensive environment? And how might one think about that differently? Looking at where you are today, and again, the various sources that people are dealing with, and their goals and what that means. So again, this whole element of time becomes an important part of the conversation. Now, as I mentioned, CO2 emissions, certainly as we work with many urban institutions that have signed commitments to reduce their levels of CO2 emissions as a result of the President's climate commitment, which is an organization here in North America that institutions are signing up to set dates for target climate neutrality. One, understanding the sources and scopes of emissions and what the various sources are. And in many cases, it will be purchased electricity, certainly in a southern institution. As you move further north, it's a little different. And just comparing some of the data we've collected over the years, if you look at land-grant university in the northern U.S., most of their consumption or CO2 emissions, in this case anyway, was from on-campus combustion for heating. And then as you move to the south, where they're air conditioning more, it becomes more of an electrical load. So the grid and the grid you're a part of become important considerations. As you look at commuter campuses, it's different. Obviously, more people are commuting. There's smaller square footage. They're getting more use of their space. So the energy profile of these various institutions changes dramatically as you move across the country. Now, one issue we have certainly is we can plan all we want for bicycle use and walking and transit, but the fleet in the U.S. is it's pretty, well, we're number one, that's for sure, in grams of CO2 per kilometer. That will hopefully change over time, but just what we drive has a tremendous impact as we start trying to figure this particular problem out. So over time, hopefully we'll make significant improvements here. We also work to help people understand what emissions mean broadly, but what does it mean at the per capita level or the FTE level in the case of an institution, or even at the square footage level. These are all metrics that are being used to compare various institutions. And again, where do they want to be in some years' time? Also, materials and waste. There are many things to deal with here, but just a lot of institutions are taking quite seriously the lead radius. Where are they getting their materials? And this can certainly be true for urban environments. What are your opportunities within that region to get the materials you need for construction? And then waste management, a big issue on many campuses and certainly in many cities as well. Finally, operational costs in economic development. These are areas where we've started mapping out, again, like we saw in one of the initial slides, the impact of not operating a facility or an environment, an urban environment or a campus environment to its full potential. The cost of operations can increase dramatically in those months where you just don't have the population there distributed. So the patterns and flow of people become important as we consider these initiatives. And then finally, economic development, because we're taking this to the planning level, we really want to understand how various elements of the urban environment can be made to work such that you're supporting business, you're supporting community development, you're supporting other initiatives. So this leads to a mapping exercise where we try to understand the location and the various population levels and relating this back to transit. How do we deliver people where we can not only support transit, make their experience better, but also support the business community in the process of doing that. And just briefly, one of the case studies, the University of Maine, I'm just going to go to a few ways that we're trying to help people understand graphically the comprehensive nature of what we do, dealing with habitats, the way we're in water resources comprehensively, access and mobility in a comprehensive manner, and then energy and emissions, dealing with those key areas in the planning process. Also helping them think of land use differently, and this is by policy. You think about, well, what can we feasibly walk in an environment? Where do we have infrastructure investment? And how through policy can we begin to focus inward investment rather than continued sprawl? Use what you have better and focus the investment into areas where you know you can really make a difference. So policies such as growth boundaries become important. So thank you. I know I covered a lot of material, but thank you for your opportunity.
When Sasaki is helping a client set a baseline or a target for carbon emissions or water reduction, what is a good metric that you use? Are you looking at what other campuses are doing? Are you looking at state requirements? Like you showed 20% up there. Yeah. A lot of people just pull 20% out of the air. What's your philosophy?
It varies greatly. Some states are setting targets. So if you're working with certain states, they will, through policy and municipal agreements, have set targets, and so that can vary. But I think you have to be careful in the comparisons for reasons noted. It varies greatly across the country. The energy sources, what you're doing with energy, whether you're air conditioning or heating. So you have to take all that on board and I think create tailored solutions to that particular environment and what they're able to achieve. I think one of the big issues we face is just the cultural differences in responding to these important issues. It varies greatly. So you kind of have to, in our minds, you really have to look at the location and what you're able to achieve in that location. So.
I have a question regarding for campuses. You showed that the efficiency per capita goes down in the summer. Obviously, if nobody's there, is there any obvious solutions to that?
Well, what we've often talked about with institutions, and I think there's a lot of discussion these days, is, well, you should be doing more in the summer. I mean, this whole notion of everyone going home to harvest crops is probably not happening these days. So, maybe there's a way to get more use out of a campus. Now, that may not, we're probably not going to yield as intensive use as you would in, say, the fall, but there would be opportunity to do better. And I think as we look at the cost of it, education, there's going to be increased pressure to better utilize resources over a year and really help people get through instead of 5 years, 4 or 3 years even. So that might be part of that solution. So.
In the interest of time, let's move on.
Okay. Okay. Thank you.